Okay, so today I'm going to explain one of the most important topics of linear programming problem, which is called simplex method. Okay, it is called simplex method. Actually, the meaning of the word simplex is, if you have gone through my video on convex set, probably it is mentioned over here. And if it is not, then I'm mentioning it right now. Simplex is actually an n-dimensional convex polyhedron n-dimensional convex polyhedron with n+1 vertices. N-dimensional convex polyhedron with n+1 vertices. That is the meaning of simplex, actually, mathematically. I'm going to discuss the algorithm of simplex method first of all, how to solve a system of equation or system of inequation using this method, and later I shall tell you why this name, what is the connection between the name, the definition of simplex with the method. Okay, probably while looking at the algorithm, which will be discussed right now, you will not be able to connect the definition with the algorithm, because algorithm is something different. Okay, as it is mentioned over here, that simplex is an n-dimensional convex polyhedron with n+1 vertices. Although I have written this, I'm not going to do any kind of geometry over here. Simplex method is an algebraic method, and a set of algebraical algorithms will be used to solve the system of equation. Okay. Now, to make you understand the methodology, let us consider a problem, a very simple problem. Say, for example, I'm considering the problem which is given as follows. Max capital Z is equal to 2x1 plus 3x2 subject to x plus y less than or equal to 1, 2x plus 2y greater than or equal to 4, x comma y greater than or equal to 0. Immediately you can see that this probably you have done this problem as I gave you as homework. This problem has actually no solution. The answer is known to me. This problem has no solution because it has no common feasible region. Okay, if you can draw the graph quickly, you will be able to see that one region falls below the line 1. If it is line 1, it falls below the line 1, and another region falls above the line 2. So these two regions do not have any common variables, common values of x and y, which satisfy both the inequations. So since no common feasible region exists, the system has no solution. Graphically, we can find it very well. I'm going to explain how to do this kind of problem with the method known as simplex method. Actually, simplex method is used when the number of variables is more than 2. Okay, because for more than 2 variables, it is not possible for us to draw the graph and mark the regions. But since you are novice to this particular method, so therefore I have chosen this simple example, because algebraic simplex method can be used for any number of variables. So I have decided to first consider this inequation, because this solution is known to us. And the form of the problem is, as it is given, is the general form of LPP. Why it is the general form of LPP? Because you can see in this in this particular problem, objective function is there. It is objective function. Constraints are there, and constraints are inequalities. Okay, so therefore it is the general form of LPP. So step number 1, as I'm writing now, step number 1 of the simplex method says that we have to convert the system of inequations into equations, first of all, because inequations cannot be solved using algebraic method. So we have to convert the system of inequations into equations. Okay, so for this, what we have to do is that in the place where inequality symbol, lesser than inequality symbol is there, what does that mean? It means that the left hand side of the inequation is less than the right hand side of the inequation. So left hand side is less, I mean, right hand side is heavier and the left hand side is lighter. So we have to keep the balance, we have to put some kind of weight on the left hand side, and to make that balance, to make the tiltness balanced. Okay, so since less than left hand side of the inequation is actually lesser than the right hand side, we are going to add a hypothetical variable on the left hand side, okay, to make the inequality a pure equality. So I'm writing over here. So to make left hand, to make lesser than type inequality, we have to make lesser than type inequality an equality, we have to add a kind of hypothetical variable, known as slack variable. It is called slack variable. Okay, and similarly, to make greater than type inequality an equality, we subtract a kind of hypothetical variable known as surplus variable. Okay, so this is the first thing you are going to do with the system of equation. I think you are writing this particular step in your copy, so I'm giving you some time. Meanwhile, whatever I have written in step number 1, I'm going to do it. I'm going to implement this in the system. Okay, so since the first inequality is lesser than type inequality and the second inequality is the greater than type inequality, in the first inequality I'm going to add slack variable. On the second inequality I'm going to add I'm going to subtract the surplus variable. Okay, so the constraints now become x plus y plus, say I'm naming a variable of my choice. It is S1, which is your slack variable because it is getting added, which is equal to 1, and 2x plus 2y. I'm subtracting because it was the greater than type inequality. So I'm naming it as S2, which is equal to 4. Okay. So we have got two equations out of two inequations. And these variables S1 and S2, they are hypothetical variables that do not have any physical significance. So we only introduce these variables so that we can apply the algebraic method. They have no practical relevance because every linear programming problem is associated with one physical system. In physical system, the original variables are x and y. Okay, sorry, one thing I have to make correct, that initially I wrote x1 and x2. It would be nice if I write x and y. Okay. So in place of x1, I'm writing x, and in place of x2, I'm writing y. Okay, these are the two variables, or these are the variables which directly come from the physical system. But suppose we are not able to solve it graphically, then in that case, we are going to apply Simplex method. But since Simplex method is an algebraic method, it cannot solve inequations. So we are going to make them equations by adding slack variable on the lesser than type of inequality and subtracting surplus variable from the greater than type of inequality in the greater than type of inequality. So we have done this, and although these slack variable and surplus variable do not have any practical significance, they will be treated as hypothetical physical variable, and therefore, but S1, S2 are hypothetical physical variables with no practical relevance. Okay, and therefore I'm writing over here, and therefore the last inequality, that means this one, will be transformed into this form: x comma y, that was greater than or equal to 0. S1 and S2, they are also non-negative. Okay, in linear programming problem, every variable is non-negative. Remember this. Next question, we have got this. We have transformed these constraints into the standard form. What about the objective function? Will there be any change in the objective function? Now, let us write this note. The per unit contribution of slack and surplus variable, the per unit contribution of the slack and surplus variable to the objective function, will be 0. Otherwise, if we do not do so, the original objective function will be distorted, and we do not want this. Okay, so we shall write the objective function as follows. Therefore, the objective function will be written as max z 2x plus 3y plus 0 into S1 plus 0 into S2. Why is it so? Because during the process, if you get any values of S1 and S2, if we put it over here, if suppose this coefficient of S1 and coefficient of S2 is not 0, if I'm putting something else, some non-zero value over here as coefficient, and if I get values for S1 and S2, then I have to put that value in the objective function, and my objective function will be changed. That will be 2x plus 3y plus some non-negative, some non-zero constant multiplied by S1. So the objective function will be same. Suppose 2x plus 3y is my profit. Actually, it was my profit, total profit. Now, since I am putting a non-zero constant as the per unit contribution of the slack variable, my profit will be changed, and this is not expected. Therefore, the per unit contributions are treated to be 0 and 0 for slack and surplus variable. And thus we get that this objective function is subject to the constraints x plus y plus s1 is equal to 1, 2x plus 2y minus s2 is equal to 4, and x comma y comma s1 comma s2 greater than or equal to 0. This type of form is called the standard form of LPP. Why it is called standard form of LPP? Because there is no inequality symbol is over there. Standard form of LPP. Standard form of LPP only contains equality symbol. Okay. Now you see one thing, when you were in school and you tried to solve the system of equation, you always dealt with problems where number of variables and number of equations were same. And if in a system of equation, number of variable and number of equations are same, we actually get unique solution. But here we can see that the number of variable and number of equations are unequal. So we have to note it down. So here we see number of variables is equal to 4 because 1, 2, 3, 4 variables are present, and number of equations is 2. Number of equations is 2. So we have to apply a kind of methodology over here to solve the system. What type of methodology? I don't know whether you have done this kind of things. Those who have come from the background with mathematics, they probably know this term called linear algebra, where they used to solve a system of equations. Okay, so here is I'm putting this result as a kind of theorem. What shall we do in this kind of scenario is that if the system has n variables and m equations where n is greater than m, then to solve the system, we assume n minus m variables to be 0. We shall put n minus m variables to be 0. The remaining system with m equations and m unknowns, remaining system with m equations and m unknowns are then solved, and the values of m variables are found. These m variables are called basic variables, and n minus m are non-basic variables. Okay, so this is the rule which we apply in this particular kind of scenario. So we try to find out the number of variables and number of equations. If number of variable is greater than number of equation, we put n minus m variables to be 0, and then we solve the remaining system for m equations and m unknowns. we find the values of m variables. Those m variables are called basic variables, and the variables which are assumed to be 0 are called non-basic variables. Now, now listen to me very carefully. This part is very important. Okay, so pay attention. If I go by this rule, and this is the rule which will be played over and over again and again. So if we go by this rule, here I can find that number of variable is 4 and number of equation is 2. Okay, don't write anything. First you listen to me. Here I can see that number of variable is 4 and number of equation is 2. So according to the rule, I have to put n minus m, don't write n minus m minus is equal to 4 minus 2, that is 2 variables to be 0. Okay, now if I do so, let us try to put original variables x and y to be 0. Let us try to put it. Original variable x is equal to 0 and original variable y to be equal to 0. I'm treating these variables as non-basic variable initially. If I do so, then from this system, what we get? From this system, we get S1 is equal to 1 and S2 is equal to minus 4. But here lies a problem. This is a problem. S2 is coming out as minus 4. In the previous page, I have written that all the original variables, slack and surplus variable, all these variables must be non-negative. But here I am getting a variable, surplus variable, which is becoming negative. And this is not expected. This is not expected. Okay, this is not expected. So what shall we do at this at this point? If you tell me that, sir, okay, put S1 and S2 equal to 0, because any variable you can put to be 0. Then in that case, I will get a system with x plus y equal to 1 and 2x plus 2y equal to 4. And if we do so, then what will happen? So x plus y equal to 1, 2x plus 2y equal to 4. So 2x plus 2y equal to 4 gives you x plus y equal to 2. So x plus y equal to 1 and x plus y equal to 2. Try to solve it. Then some absurdity will come. 0 equal to 1. Okay, if you do in this particular manner. So here we have to do some kind of trick in this type of scenario. What sort of trick? Because the standard form which you have got is not the desired standard form. Something else has to be done to get a proper standard form of the system. I'm not erasing anything. Let us keep it over here because it should be in front of you always. So I have to do with the system something else. So in the next page, I'm going to write what am I supposed to do now. Okay. So the point is, the trick is whenever there is a surplus variable, it is always associated by a variable called artificial variable. Artificial variable denoted generally by capital A, and the per unit contribution of the artificial variable in the objective function is considered to be a non-zero large hypothetical figure denoted by M. Non-zero large hypothetical figure denoted by M, where M is also positive. So this is the trick. I know that there are some questions which are coming to your mind. I'll answer to your questions. First of all, let us try to apply the trick to our given system of equation. So with this trick, my system thus becomes max z is equal to 2x plus 3y 0 into S1 plus 0 into S2. Or one more thing, the per unit contribution, let me write it over here. The amount M will be subtracted from the objective function. So here I'm adding the per unit contribution plus 0 S1 plus 0 S2. But in case of artificial variable, it will be subtracted like this. So that's why I'm writing minus M into A. Try to read the paragraph and try to correlate what I've written over here. Okay. Subject to x plus y plus S1 is equal to 1. Subject to x plus y plus S1 equal to 1. Here, artificial variable will not be present in the first equation, because I have written already that artificial variable is always associated with a surplus variable. When there is a surplus variable, their artificial variable will appear, because the problem was actually created by surplus variable and not the slack variable. So we are writing it as x plus y, 2x plus 2y minus S2 plus A, which is equal to 4. And then we are going to write x comma y, S1 comma S2 comma A greater than or equal to 0. Okay, so this is my required standard form of LPP. Now, the problem which we faced in the earlier page, let us try to find out whether the problem still prevails or not. Okay, so now we are going to count number of variable. We are going to count the number of variables, which is n is equal to, how many variables are now present? 1, 2, 3, 4, 5. 5 variables are present, and number of equations m is equal to 2. So according to the rule, we have to select 5 minus 2 non-basic variables. Okay, 5 minus 2 non-basic variables. 5 minus 2 non-basic variables, that is 3 non-basic variables. There is a convention which I'm going to make right now. The convention is that first of all, to choose the variables, to non-basic variables, start with the original one. So let us first put x to be 0 and y to be 0. That is the convention. Now, out of 3 variables, 2 non-basic variables with 0 value have been selected. 1 variable is still remaining. Now, take S2, that surplus variable, and make it 0, because surplus variable created the problem. So first you start with a non-original variable, and then you select the surplus variable. If I do this convention, if I make this trick and do this convention, then from this we are going to get, If I put x and y equals 0 over here, s2 0 over here, then by putting these, we get s1 equal to 1 and a is equal to 4. So these are basic variables. These are called basic variables, and these are called non-basic variables. Okay, now in the basic variable, we do not have any trace of the original variables. Now our objective is to make a simplex table, and from that simplex table, I'm going to do some kind of operations, matrix operations, by which we are going to eliminate the undesired values, undesired variables, and I'm going to introduce the original variables which are the part of the system. Now the important question, the particular question is actually coming to your mind, if I am not wrong, that when that slack variable and surplus variable, these are hypothetical variables, their per unit contribution is 0. And these hypothetical variables have no physical significance, practical relevance. Artificial variable is also helping me to solve the system. Artificial variable doesn't also have any practical significance. Okay, and it is also non-negative, but its per unit contribution has not been taken into consideration, is to be 0. Its per unit contribution has not been taken to be 0. Its per unit contribution is rather taken to be a large number, capital M. Now you may ask me this question, that if during the process, if you get the value of the artificial variable, and if I substitute that value in the objective function, then the objective function is getting changed. But earlier you said that zeros have been put by keeping in mind that if I get s1 and s2 to be some kind of is having some kind of value, then if I put them, they shouldn't change the objective function. But if I get artificial variables value, and if I substitute that in the objective function, then it is changing. So why did you put m? Why didn't you put 0? Artificial variable is a kind of indicator. It is a kind of indicator. Okay, artificial variable is a kind of indicator. We have put the value of artificial, we have put the per unit contribution of the artificial variable to be a positive number. Yes, indeed. But we will try to eliminate artificial variable from the chart. Or you can say, we will try to allot 0 value to the artificial variable. Okay, so if I get 0 value for the artificial variable, then that problem which is coming to your mind, that confusion which is coming to your mind, that will be erased. Okay, and if I am failing, if we fail to do so, that is, if we are unable to eliminate artificial variable from the chart, by chart I mean the simplex table, then we'll say that system has no solution. System has no solution, which we are supposed to get in the problem. in the given problem, because you already know in the given problem the system has no solution. So probably when I'll be applying the simplex method, probably will not be able to eliminate artificial variable from the chart. And why I'm saying that the artificial variable is the indicator, presence of the artificial variable in the simplex table eliminates the possibility of the system of having sort of solution. But if the artificial variable is not present, or it is present with zero value, then we are going to get some kind of solution. Okay. Why am I saying some kind of solution? Because in that case, you may have you may get a unique solution, or you may get unbounded solution. Various other, you may get degenerate solution. Many various cases may arise. Okay. So I think that I must stop at this point, because time is running out, and after 1 minute, the session will be disconnected. You copy this particular standard form. When in the next session, I'm going to draw the simplex table on the basis of this particular system. If I do any mistake in writing the coefficients or whatever, you correct me by writing in the chat box. Okay.